Well, good morning, afternoon, evening, whatever it is. Today I'm going to take a look at illustrating the method of reducing a matrix further from echelon form to something called reduced row echelon form. We'll do an example by hand just to show how it works. It works very much like we've already done. But then we'll take a look with Mathematica and see how it works on Mathematica. And let's work with an example. This example is from last time's worksheet. So here is the original matrix M, 0, 0, 2, 4, 4, 1, 2, 1, 2, 1, 0, 1, 2, 4, 8, and 1, 2, 4, 5, 7. So last time we did a bunch of steps in here, elementary row ops, elementary row operations. We used those. And we reduced that matrix to a point where we could find what the solution looked like. Four variables, 3 rows in the echelon form. So this is an echelon form. Every row, if a row begins with a number, then zeros precede it. And so we have echelon form here. This last row tells you that the last variable, we have 4 variables, 1, 2, 3, 4, and a constant. This is an augmented coefficient matrix. So there's one free variable. So one free variable with 4 total variables tells you that what we're dealing with is a line in 4-dimensional space. So the free variable tells you a line for the geometry, and the 4 total variables tells you you're looking at 4 space. So now, in a sense, we know what the solution looks like. We don't have it completely, but now I'd like to reduce this further. And to reduce it further, what I'd like to do, I'll do a couple steps and then I'll give the final result. So the first step I'm going to do with this one is to replace row 3 by 1/2 of row 3. So the old row 3 goes to 1/2 of row 3. Everything else stays the same. So 1, 2, 1, 2, 1 remains the same. 0, 1, 2, 4, 8, 0, 0, 1, 2, 2, 0, 0, 0, 0, 0. And a couple of you have asked me about whether echelon form means that you have to have 1s as the leading non-zero entry in every row. It doesn't. This is echelon form, but in the further reduction, we do require that. If a row has all zeros, then of course there is no non-zero term. But if a row does have a non-zero term, the first non-zero term in that row has to be a 1. And you can always accomplish that like that. But we're going to do further reductions. My next reduction is going to take this number here. Well, maybe we could do it either, well, yeah, let's take this number here. I'm going to use this number and take -2 times this row and add to the row before. That will put a 0 here. So the new row 3 will become, row 2 rather. Row 2 will become -2 times row 3 added to the old row 2. When we do that, we're going to get first row remains the same. 0, 1. Now this remains a 1 because minus 2 times 1, minus 2 times 0 plus 1 is 1. The next term is 0. Minus 2 times this plus this also gives 0. Minus 2 times this is minus 4 plus this is 4. And the third row remains the same. And the last row remains all zeros. These positions, the first non-zero term in each row, these are called pivot positions. And what I just did is I used this pivot position just to change the row above that pivot position to a 0. And the next step would be to zero out this one. So use this pivot position to zero out the terms above it if they have any. So this is how you would do it by hand. You again use the elementary row operations. But what I wanted to show you today was how to do this using Mathematica, because that's how we're going to do it. I mean, you don't want to be doing all this by hand all the time. So I'll open Mathematica first, and then I'll show you my screen. So let's see, where's Mathematica? There she is. All right. So I'm going to share screen with you. So hopefully this is what you're seeing. Now I'm going to enter the matrix into Mathematica. So I'll call the matrix M. Mathematica, please. Yeah, there we go. M equals, and matrices are entered as actually tables. So this will be a table. I'm going to use a curly bracket here, and then by rows. So the first row is 1, 2, 1, 2, 1. That a curly bracket ended that row. Then I go to the second row, which is 0, 1, 2. Well, I'll tell you what. Let's start over. And let's do the actual original matrix, 0, 0, 2, 4, 4. That's the first row, 0, 0, 2, 4, 4 of the original. The second row is the 1, 2, 1, 2, 1. The third row, 0, 1, 2, 4, 8. And the last row, 1, 2, 4, 5, 7. So that ended the last row, but I have to end the matrix. So beginning and end, you have 2 curly brackets, or curly brackets around the number of rows that you have. I'm just going to enter this, hit the enter button to give me another line. And now the Mathematica command that I'm going to use is RowReduce. It's come up there. Bracket for Mathematica means do something with this. So here we're going to RowReduce M. And now I'm going to hold down the Shift button and hit return at the same time. So Mathematica did it, but it's in this same table form that I had before. So there are a number of ways to change this to matrix form. One of them is to use this display as, and if you pull down, you can display it as a matrix. There it is. And notice in the line that they added, this was an entry line where you added matrix form, or you had matrix form of the result, and it gave you the result as the matrix form. Let me do that a different way. I'm going to delete this output right now. And we could, now I'm going to input again, and I'm going to write the word matrix form. And to indicate I want the matrix form of the very last line, the output from the very last line, you use a % sign. Hold down the Shift key, hit return, and it again gives it to you. One other thing we could have done, I'm going to eliminate this output again. Let's eliminate this output also. So back where we started, I'm going to have it do the matrix form immediately. So matrix form bracket, and then I need another pairing bracket right at the end, and it'll give the answer right away. So there we go. So the final reduced row echelon form for this, I'm going to write it on the board and then go back to the video. So the final reduced row echelon form, 1, 3 zeros and a -9. 0, 1, 2 zeros and a 4. 0, 0, 1, 0, 2, and then all zeros. So here we go. Here it is, and this is the reduced row echelon form. Notice that for every pivot position now you have zeros above and below. So that is kind of the key difference. Same pivot positions, different values, at least for that one, and zeros above and below. Okay, so now we can write out the solutions. X1 equals -9. When I did this before, I think I got something else. Hang on. Well, this is what I got this time. So X1 is -1, X2 is 4, X3 is 2, and X4 is free. So is equal to S. So the solution in this case would be 9, 4, 2, S, and S is any real number, which means it's a free variable. So that's the solution. So this is what we will be using when we solve linear systems now. We will set it up. We will import into Mathematica and bypass all these elementary row ops. We will get the final form and we will evaluate it. And that's what the homework will be on, and we'll do a little worksheet on this tomorrow. So hope this was instructive. Make sure your Mathematica is working. If your Mathematica has issues, one of the things that you can use while those issues are being straightened out is an online program called Wolfram Alpha. If you search for this, you will find it online. It's an online app, and it does most of the Mathematica we're going to do for a little while. You can actually do on Alpha. If you have the app working, I would use the app. I do anyway. But Alpha is a good choice. And I know that for some of you, you have Mathematica issues right now. In any case, I will see you tomorrow, and have a good evening.